Welcome to a lesson on multiplying decimals. Here's the procedure to multiply decimals. Number one, we'll multiply the numbers just as you would multiply whole numbers. Next, we'll find the sum of the decimal places in the factors. Then we'll place the decimal point in the product so that the product has the same number of decimal places as the sum of the total number of decimal places. And we may need to write zeros to the left of the number if needed. So let's look at an example and then we'll explain why we have to do what we're doing. Let's go ahead and write this vertically. So what we'll do first is just multiply ignoring the decimals. So we're going to have 52 times 2. So 2 times 2 would be 4 and 2 times 5 would be 10. Next, this number has one digit to the right of the decimal. And this one also has 1. 1 plus 1 equals 2. So this product must have 2 digits to the right of the decimal. So starting on the right, we'll count over 2 digits to the left. 1, 2. So this product is equal to 1.04 or 1 400ths. Converting these to fractions might explain why this process actually works. Meaning 5.2 is equal to 5 2/10, which would equal 52 tenths. 0.2 is equal to 2/10. So this same product in fraction form would be 52 over 10 times 2 over 10. And we know when we multiply fractions, we simply multiply across the top and multiply across the bottom. So what we'll notice when we multiply our denominators together, we're going to get 10 times 10 or 100, and our numerator is going to be 104. Well, this is an improper fraction that can be written as 1 400ths, which obviously matches our product in decimal form. So the reason we're having to sum the total number of digits to the right of the decimal is because we're really determining what the denominator would be in fraction form as some power of 10. Let's go and take a look at another one. 12.3 times 0.15. Notice that it's not important to line up the decimal points as we did when we were adding or subtracting. So now we're going to go ahead and multiply as we normally would, ignoring the decimals. So we'll multiply by 5 first. 5 times 3 would be 15. We carry 1. 5 times 2 would be 10. Plus 1, that would be 11. Carry 1. And 5 times 1 would be 5. Plus 1, that would be 6. Now for the next row, we'll add a 0 here and then multiply by 1. So we'll have 1 times 3, 1 times 2, and 1 times 1. This should be reviewed when we multiplied whole numbers. Now we'll add 5, 4, 8, 1. Now we can't forget about our decimal. This number had 1 decimal place, this one had 2. 1 plus 2 would be 3, so the product must have 3 decimal places. So we start on the right and count over to the left 3 places. 1, 2, 3. Our product must have 3 digits to the right of the decimal, and now it does. And let's try another. On this last example, remember that if we have a product, let's say 2 times 3, that is equal to 3 times 2. That's called the commutative property of multiplication. So we can change the order of this if we want. So what we'll notice on this problem, if we were to write 15.78 times 0.002, it'll be a lot cleaner if we multiply them in this order rather than the given order, and the product will be the same. So we'll go ahead and multiply by 2. 8 times 2 would be 16. We carry the 1. 2 times 7 is 14 plus 1. 15. Carry the 1. 2 times 5, that's 10 plus 1. That's 11. Carry the 1. And finally 2 times 1 would be 2 plus 1. That'd be 3. Now this number has 2 digits to the right of the decimal. This one has 3. So our product must have 5 digits to the right of the decimal. So we start on the right and we count over 1, 2, 3, 4. We have to go 1 more digit, so we have to add an extra 0. And our decimal point would be here. So as the note suggested, if we don't have enough digits, we do have to add extra zeros to the left. I do want to take a moment now and talk about multiplying a decimal by a power of 10. This can be done very quickly and easily since since our number system is based on powers of 10. To multiply a decimal by a power of 10, we move the decimal point to the right the same number of places as the number of zeros in the power of 10. And it may be necessary to add zeros at the end of the number if there aren't enough digits. So for example, what this is telling us is if we multiply 5.378 times 100, there are 2 zeros in this power of 10, so we can just take the decimal point and move it to the right 2 places. If you ever get confused on which direction to move it, when we multiply by 100, the number must get larger, therefore it must move from left to right. So this product would be 537.8. Let's take a moment to explain why this shortcut works. If we rewrote this in fraction form, it would be 5 and 378 over 1,000, or 5,378 over 1,000 times 100. If we multiply this by 100, this would actually simplify. This would become a 1, this would become a 10. So right away we can see our denominator would be 10, therefore our product should be in tenths, as we see here. And we would have 5,378 tenths, which should be 537 and 8 tenths. And that does match our answer using the shortcut method. Let's do a couple more using this shortcut. 1,000 is actually 10 to the third power. The number of zeros in this power of 10 will always be the same as the exponent on base 10. What that means is to multiply by 1,000, we can take 78.3 and move the decimal to the right 3 places. So 1, 2, 3. We didn't have enough digits, so we do have to add some zeros here. So this product would be 78,300. On the second example, again, we can change the order of this product. In this case, I would advise that. So in this problem, we'll take advantage of the commutative property multiplication and change the order. So now we can just take 12.34985 and move the decimal place to the right 4 places because there are 4 zeros in 10,000. So 1, 2, 3, 4. The decimal point will be between the 8 and the 5. And we should rewrite this. It'll be 123,498 and 5 tenths. Okay, that'll do it for this video. Thank you for watching.